Everyone, today I would like to discuss this very interesting math problem. I think it is also a past PSLE math question. Right? I make it even more interesting by adding two more questions. Right? Part C and Part D are not found in the original question. Okay, so stay tuned. Let's read the question together. The diagram shows an empty tank measuring 45 centimeters by 15 centimeters by 42 centimeters. At 2 p.m., tap X was turned on, filling the tank with water flowing at the rate of 4.2 liters per minute. Then after 5 minutes, tap Y was turned on to drain the water out of the tank. Right, then at 2:15 p.m. the tank was half filled with water. The first question is, what was the rate of water from tap Y, and what fraction of the tank was filled with water at 2:30 p.m. Additional question: does the water level always decreases when tap Y is open? Can it increase instead? And what is the condition if that is so? And part D: can the answer to part B be negative, and what does it mean? Right, so let's conceptualize what is actually happening in this problem. So we have a tank, and then there is a tap X in which water will be flowing in at the rate of 4.2 liters per minute. Right? This tap X will be open at 2 p.m. Then there is a tap Y, which is draining the water out of the tank. What is the rate? We do not know. That is what we are going to find out in part A of the question. But when does tap Y open? It opens at 2:05 p.m., 5 minutes later. Right? Then we are told that at 2:15 p.m. the water level in the tank is half full, right? Something like that. So that means at that time tap X would have been operating or on for 15 minutes, while tap Y at 2:15 would have been open for only 10 minutes, 5 minutes lesser. So now we are talking three volumes here. The first one is Vx. I call it Vx. It will be the amount of water that the tap X would be filling onto the tank after 15 minutes. And then we have Vy, which is the volume of water that will be drained out of the tank from 2:05 to 2:15, or for a duration of 10 minutes. And then we have the volume of the tank. Then we are interested in half of it at 2:15. Okay, so what is the relationship between all these three? We're going to take Vx minus Vy, because Vx is the volume of water that is going into the tank, but Vy is the volume of water that is going out of the tank. Right? So after at 2:15, this equation Vx minus Vy will be equal exactly to half of Vt. Right. So what is Vx? Vx will be the rate of the water, 4.2, and then multiply by 15 minutes, 15. What about Vy? Vy, we do not know the rate. Right, so I put a question mark there, but then that whatever that value is must be multiplied by 10 minutes, and that should be equal to half of Vt. So let's calculate what Vt is. Vt is the volume of the tank. It is length times breadth times height. Right, so what is the length? 45 multiplied by 15 multiplied by 42. Right, since these are all in centimeters, we have to divide this volume by 1000 to convert it into liters. Right, so if you were to press your calculator, I believe you're going to get 28 28.35 liters. Okay, but that is the full tank. We are interested in half of that. So half of VT will be 28.35 divided by 2. That will give us 14.175 liters. Right, so let's plug that one in. 14.175. So how do we find this rate for tap Y? Little bit of manipulation, right? So we need to take 4.2 times 15 minus 14.175 and take the whole thing divided by 10 minutes. Right, so you were to press your calculator, you're going to get, I believe, this number 4.8825 liter per minute. Or if you are interested in the exact fraction, I think it is 1953 divided by 400. Okay, so that's the answer for part A. So now let's tackle part B. What fraction of the tank was filled with water at 2:30 p.m.? Right, so at 2:30 p.m. X would have been operated for 30 minutes because it was open at 2 p.m. while tap Y will only have been open for 25 minutes, 5 minutes lesser. Right, and then earlier in part A we found out that the rate for tap Y is 4.8825 liters per minute, and for X it is given here as 4.2 liters per minute. Right, so it is quite easy to do, right? So we take 4.2 multiplied by 30 and then minus 4.8825 multiplied by 25. Right, I believe you are going to get 3.9375. Right, but the question wants the fraction. Right, so we have to take this number and divide that by the volume of the tank, which we also have calculated earlier. That number was 28.35. Right, so if you were to press your calculator, I think you're going to get this number, 0.13889. Right, we round it up to 4 or 5 decimal places, but the exact fraction I think is 5/36. Right, so that's the answer for part B. Problem that we have just solved. Right, so let's click on this answer button. That is the answer, so that's what we have gotten just now. Right, so now is the interesting part. Right, let's take a look at what the simulation will show us. Right, so I'm going to press this. Right, so you can see that the water level initially rises and after that it starts to decrease. Right, of course you can expect that. Let's drag this back, right, to times 0, and then I'm going to put it to about 2.05 just before it turns to 2.06. Right, so you can see that after 2.05 the water level will start to decrease. That is when tap Y is open. Why does it decrease? It is because the rate for tap Y is 4.8825 while the rate for tap X is 4.2, which is smaller. In other words, the moment tap Y is open, there will be a net outflow of water from the tank. Right, that is why the water level will start to decrease. Right, but then let's take a look at another example. Okay, this one is a bit is different. All the numbers are different, but take a look at the answer for part A. Right, in this particular case, the rate for tap X is 3 liters per minute, but for tap Y it is 1.6875, which is lower. So what will happen? Let's take a look at the simulation. Right, so you can see that the water level keep on increasing even after 2.04, which is when tap Y was open for this particular case. Right? Why is that so? It is because the rate for tap Y is 1.68. It is smaller than tap X. Alright, so even though it is open, there will still be a net inflow into the tank, but now it is at a slightly smaller rate than initially, right? Because some water will be flowing out. Right, and let's take a look at the last case. Right, this one is interesting. You'll find that for part B, you'll get a negative answer. Okay, let's take a look at the simulation and see what happens. Right, so you can see that just before the end at 2:30, the water level has reached 0 in depth, and then after that it goes down. So what does it mean? It actually means that the tank will be empty at that time. Before I end the video, I just want to make one last point. Even though I didn't include it inside my modeling or design of this question, but for part B, it is also actually possible to get a fraction which is greater than 1. Right? I think given enough time, in some cases, you can get more than 1. So what does it mean if you get a fraction more than 1? It would mean that the volume will be greater than the volume of the tank itself. So that will mean there will be some overflowing of water from the tank. Okay, so I think that's all I want to share. I think this problem will make a very nice exercise for students. We can divide them into groups, and then each group will do a different set of numbers, so that we get the 3 different scenarios that we have discussed in this video. Okay, so students, go ahead and go to the link as given in the description below. Try out a few problems, change the numbers, and make sure you can do everything all by yourself. Okay, so have fun, and thank you for listening.